Find the equivalent capacitance for the circuit shown. Also find the charge and potential difference across the C1 and C6 capacitors. So you know that capacitors 2 and 3 are in parallel, so we say C7. Since we have 6 capacitors, let's use 7. C7 is equal to C3 plus C2 plus C3, and that is 1 microfarad plus 5 microfarad. That will give us 1 microfarad plus 5 microfarad. That is 6 microfarad. So I'm going to do it stage wise. So the equivalent circuit now becomes this now our C7, this is our C1. This is our C4. This is our C5. This is our C6. This is the battery. 12-volt battery. So the next thing is to get C8 from the arrangement C4 and C5, which is also parallel. C4 is parallel to C5. So we have that therefore C8 is equal to C4 plus C5, and that's C4 is 1 microfarad, so 1 microfarad plus 3 microfarad, that's 4 microfarad. So C8 is 4 microfarad, and equivalent circuit now becomes so this is C1, C7, C8, C6. So we now have C6. C6 is or C1 is in series with C7. So you say 1 over C9 is equal to 1 over C1 plus 1 over C7, and that will give us, if we find the LCM, C1 C7, which is C7 plus C1. Therefore C9 is equal to product over sum. Product over sum is equal to 3 microfarad times 6 microfarad all over 3 plus is 9 microfarad. Microfarad will cancel 1. You have 2, which is 2 microfarad. Therefore C9 is 2 microfarad. Therefore our equivalent circuit will become C9, C8, C6, then the battery, which is 12 volts. So we do the same thing to series connection of a C8 and C6, and that will give us we have 9 already, C10, So C10, if we told this line is product over sum, and the product will be C6 C8 all over C6 plus C8, and you have 4 microfarad times 2 microfarad all over sum is 6 microfarad. So you have, let's leave it in fraction, 4 over 3 microfarad. So the arrangement becomes C9 C10. Remember how we are going about it. C10. So that's the circuit that ensues, but C9 is parallel to C10. Therefore, C11, which is C equivalent, is equal to the sum, which is 2 plus 4 over 3 microfarad. And that will give you, if you find the LCM, 164, that is 10 over 3 microfarad. That's equivalent, or approximately 3.33 microfarad. So the next thing now to do is to find the volt. So when you look at this last one, you see that C9 and C10 are connected in parallel, so they have equal voltage, they have the same potential across them. So we now say that V9 is equal to V10 V9 is equal to V10 and is equal to 12 volts, Therefore we know that Q is equal to CV. Q is equal, that is it. Therefore the charge across it is Q9 is equal to C9 V9 and is equal to Q10 and is equal to, okay, let's put this one in bracket, and is equal to C10 V10 is equal to C10 V10. So from here we find out that Q9 is equal to C9 is 2 microfarad, so it's equal to 2 times 10 raised to the power minus 6, 2 times 10 raised to the power minus 6 times 12, and that will give us 24 microcoulomb. Q9 is equal to 24 microcoulomb. In that manner, let's also put this one in brackets. Q10 is equal to, remember Q10 is this, 4 over 3 times 10 raised to the power minus 6 times 12 volts. So you have 4, that's is equal to 16 microcoulomb. So we are looking for the voltage across capacitor 1 and capacitor 6. So we now say V10 is equal to V8 plus V6. In order to get this 10, C10, we did this, which is in series. So the voltage across here, this point, let's say it's A and B, is same thing as here, A and B. So that's why we added them. We already established that this other one, V10, is 12. 12 is equal to Q8 over C8 plus Q6 over C6. Of course, the same charge will flow across here. The same charge will flow across the two capacitors. The same charge will flow across the two capacitors. So we now have where Q8 is equal to Q6, and let's say it's equal to Q. So if that is the case, we have a Q into 1 over C8 plus 1 over C6 is equal to 12. Is equal to, if you do the LCM, you have C8 C6 over C6 plus C8 plus C8. That's what you have. So that Q, so that therefore Q is equal to Q8 is equal to Q6, and it's equal to, this one will come over here, 12 times C8 C6 over C6 plus C8, and that will give 4 microfarad times 2 microfarad all over 6 microfarad times 12. A charge of 16 microcoulomb crosses here, C8 and C6, this place. So in order to get the voltage across that, just like we have said, the voltage across it is this. The voltage across these two is that. So the voltage across this will be, you know that Q is equals to CV. So if we know Q, which is that is, we want to know V6. Therefore, V6 is equal to Q over C6, which is equal to 16 times 10 raised to the power minus 6 all over 2 microfarad is 8 volts. So that is 8 volts. We do the same thing for the other one to get it. Remember, it's equal to V1 plus V7. So we'll do the same thing that we did here. So 12 is equal to Q1 over C1 plus Q7 over C7. So where Q1 is equal to Q7 is equal to Q. So if we do the same thing, we will have Q into C1 plus C7 over product C1 C7. So if we do that, we will now have that Q is equal to Q1 is equal to Q7, and is equal to 12 times C1 C7 over C1 plus C7. C1 is equal to 3 microcoulomb, 3 microfarad, times so the 9 microfarad. So 3 here, 3 here, 1, 3 here, 4, 24 microcoulomb. So in order to find V1, we do the same thing. Therefore, V1 is equal to what we have done here, Q1 over C1. So we have that it is equal to Q1 is 24 times 10 raised to the power minus 6 all over C1 is 3 times 10 raised to the power minus 6. This one 1, this one 8, which is equal to 8 volts also. So that is how to find it. So therefore V1 is equal to 8 volts and Q1 is equal to 24 microcoulomb. V6 is equal to 8 volts and Q6 is equal to 16 microcoulomb. So that is how to solve these things. So you have to follow it stage wise. You reduce it, you continue reducing it, knowing that when they are connected in parallel you just add, when they are connected in series you do the reciprocal to give you the reciprocal of the equivalent. You add the reciprocals, so you follow that way to get the equivalent capacitance, from where you now go to walk back. You trace your step backs to get the voltage across each capacitor, and that by so doing you will systematically again walk towards what you are asked to do. That is exactly what we did, knowing that microfarad is 10 raised to the power minus 6, and you walk back and finally arrive at the answer. Thanks. Bye.